Yo, 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 peace, peace, peace. This is your boy Takori Dawson in the scene. Yeah, man, I got my show. I've been bragging about how I'm gonna have my show, how I'm have my own platform, my own YouTube stuff, man. I've been putting in a lot of work in certain parts of the conscious community when it deals with the Hebrew Israelite concepts, flat earth concepts, and other cosmologies like that. I've been doing this since 2019. I was in a Lions Den first under JJ 7000, and I was doing debates under him. And then I was started moving around to other platforms and actually representing on other platforms. And then, that's when I started to know Judah Nazarene and them from Torah Nights. Right now everything is banding together with the Torah Nights, with Lions Den, with Paradigm Shift, with all of these different type of platforms, even Sinetta Studios. All these platforms are coming together, and yes, this is a time of coming together for different platforms. So I said, hey, it's my turn to do my platform. I got a lot of information, I got a lot of work, and I put in a lot of work. I put in a lot of work for other people platforms, and it's by time I put my work in for my platform, because I feel like I deserve it. Not being, you know, not bragging or nothing like that, but I actually do me, and I'd be more than happy to continue representing my people, and representing other debate leagues and stuff like that, because they did give me a name, they did give me an opportunity and things like that. So what I'm gonna get ready and do is I'm gonna get ready to get into my lesson. My lesson is called, my lesson is actually called Globe Earth Debunking Globe Earth Ideology Part 1, Gravity. This is a very controversial thing to talk about. I absolutely gonna also do a platform. I ain't gonna say a platform, but I'm gonna actually do a playlist on certain things like flat Earth, the Bible, cosmology, media files, all of these other things. That's what I'm gonna be getting ready to do. So I gotta get my celebration on. So yeah, I gotta get my celebration on. So here's the thing. I gotta get my celebration on. So I'm gonna share this real quick. This applause. We gonna get this show on the road. Let's play this applause real quick. That's it. Okay. Now, here's a problem in the scientific community. There's a battle against flat earthers, there's a battle against globe earthers. What I did my research on is I actually found that there's a certain glue to the heliocentric model, which is gravity. Gravity is supposed to be the glue to the heliocentric model. Yeah, my bad. So to the heliocentric model. So here's the thing of what I'm gonna be doing. What I'm gonna be doing is this right here. I'm about to go and get into my screen. Oh, I'm at work, by the way. I'm gonna be going getting into my screen, and I'm actually gonna be sharing my spiel. So let's get into this presentation real quick, and we're gonna break certain things down. Okay, so this is for all you gravity lovers out there. Gravity lovers. That's all I'm gonna say. I'm about to debunk your presentation. I'm about to literally debunk your presentation. Uh, yeah, debunk. So let's go and get into it. Here's my screen right here. So a lot of globe earthers don't understand this, but I'm gonna actually break it down to them so they can get a better understanding on a model because y'all model suck. Your model suck. So since your model suck, and since your model is actually pseudo, a lot of globe birthers, and this is no shout out to. I mean, this is no shot to the people that I hang with that are globe birthers that are obsessed with the globe. Because you got globalists and you got globe birthers. You got globalists that's obsessed with the globe, and you got globe birthers who just believe that the Earth is a globe, but they don't praise it. So about 15 billion years ago, the universe formed after the Big Bang and continued to expand. Material collided and cold ascended under gravitational attraction in about 4.5 billion years ago. The Earth was formed. During the formation, all these heavy stuff like iron sunk into the center of the planet, forming our core, and the relativity light stuff, which is silicon, formed the layer above, which is the mantle. The outermost layer, which is the crust, is by far the most chemically complex and is the bit we stand on. Gravity holds planets together. If the Earth was made of homogeneous material, it would be a perfect sphere, flattened slightly by its rotation. However, because the Earth is not homogeneous, but instead has regions deep below our feet, and which is very in how dense they are. The Earth is not a perfect sphere, and is let me hide this, and is exaggerated so as views from space. So, what this is really saying is that gravity is the reason for the Earth. I mean, for a lot of things in the universe. This is what they claim. But we know right here that according to the NASA website, when you go to nasagov.com, um, and NASA, it tells you that the planets is round because of gravity. So meaning that gravity is pulling on equally on all sides. But wait a minute, hold on. Let's go back right here. I thought you fools just said that gravity is not I mean, the Earth is not a perfect sphere. But if gravity is causing the Earth to become a sphere, I mean, if gravity is pulling equally on every part, causing it to be a center of mass, I mean, at the center of mass, and it's doing this equally around the whole planet, around the whole literal circular sphere of the Earth, then I'm pretty sure it will be a perfect sphere. So here you are back here, and I'm gonna put my arrow right here. It said the Earth is not a perfect sphere and instead slightly wonky looking. See below, but these images are highly exaggerated. So, my goodness, we can hardly freaking get an actual image of the Earth. They literally said this shit was exaggerated, bro. Come on now, bro. This stuff was actually exaggerated. This is crazy. These people supposed to be giving us the truth, but yet they giving us highly exaggerated images, and these are from NASA websites. So you went from an imperfect sphere to a perfect sphere, and we know that NASA is saying that it's a perfect sphere because it says gravity pulls equal all sizes. I mean, all sizes equally. So since that's the case, then that means that I don't know, it would be a sphere. I mean, I don't know, man. But yeah, these this is why we say that gravity has contradictions to it. Let me look up something for y'all real quick. I want to look up something real quick. I really want to look up something. I want to show y'all something. I really want to look up something. Hold on, y'all. Let me look something up. I had my mic off, man. I had my mic off, man. I really had my mic off, man. I've been tripping. I'm just not doing this, man. I accidentally cut my mic off. But uh, yeah, I was actually. So here's the thing: gravity is supposed to be real. Gravity is supposed to exist. Gravity is supposed to be all of that. But let me show y'all something real quick. Let me show y'all something. Let me actually get back to it because according to this right here, gravity. First of all, gravity starts off as a contradiction. Gravity literally starts off as a contradiction because one, they tell you that the earth is not a perfect sphere on this source, and this source right here is actually from what they call it. They this source right here is actually from uh it's from NASA, really. It's literally from NASA. I got two different sources from NASA. One saying that the earth is not a perfect sphere, and indeed that earth is a perfect sphere. So the problem is the actual problem is that this what people not understanding is this actually violate the laws of logic because the laws of logic clearly says that it's supposed to be a perfect sphere. That's what it's supposed to be, but I mean not a perfect sphere, but the laws of logic mean there's no contradiction. And we clearly see that a contradiction is two yeah, it clearly says that a contradiction is pretty much two yeah, it's pretty much two opposing factors. That's what it is. Two opposing factors that's supposed to be for one method. But yet you clearly see right here that gravity is not a perfect sphere on this one, but yet gravity is supposed to be a perfect sphere right here. It doesn't say it's an oblate spheroid. It says that the planet is a sphere because gravity is supposed to pull equally on all sides. That's what it's supposed to do. Gravity is supposed to pull on all sides. That's what gravity is supposed to do. So, what people don't understand is this right here that when gravity pulls on all sides equally, that means that the shape will be perfect. So, since gravity is pulling on everything on all sides, gravity is supposed to be a perfect sphere. So, which one is it? Is gravity a perfect sphere or is it not a perfect sphere? Now, watch this. Gravity, regardless of where you're standing at, the gravitational force always point towards the center of the earth and is attractive. Why do we feel the earth's gravity force? We don't feel that force because I'm about to show y'all how much force we supposed to be feeling using their mathematical equations. Now, like I said, so gravity's supposed to pull everything towards the center of mass. Let me show y'all something. I'm gonna show y'all these tidal waves also, because I know my stuff was like probably like off. I know my stuff was off, but look at these tidal altitudes. Look at these tidal altitudes right here. Look at this. Look, these are different type of tidal altitudes, and look at these right here are amplitudes. This is what they are. And the amplitude is the height of a tide. So you got low tides and you got high tides. Watch this. I want to show y'all something because these tidal nodes literally debunk gravity. Because you can't tell me gravity is selective on ocean water. Look at this right here. You got a tidal node right here, a tidal node right here, a tidal node right here, a tidal node right here. You got several tidal nodes. And a tidal node means that there's no amplitude, period, or meaning that there's no tides, period. So gravity is selective on certain parts of the ocean. But wait a minute. Hold on, wait a minute. Let me show y'all something real quick. Look at this right here. Look at the moon's gravity. Look at the moon's gravity on the earth. According to this model right here, moon's gravity is highest where the moon is at, which would be near the equator. Because the moon has a 5-degree orbital tilt, because the moon has a 5-degree orbital tip, 5 degrees near the equator and away from the equator. You should have high tides at its highest. But according to the nodes, according to the tides, the amplitudes of the tides that we just showed y'all, that's not facts. Look, we're gonna show y'all again. Since gravity is supposed to be real, then why in the hell are these amplitudes are at its highest and they are always at the borders of these continents? They're always at the borders or near the borders. And then the furthest you go away from these borders, they get lower and lower. You can clearly see that most of the high tides are always at the borders, and then you got tidal nodes. So this is a big problem because it debunks this model. It clearly debunks this model right here. This model. It clearly debunks it. So the red tides will be the highest tide. The red on the map will be the highest tides. And the highest tides, all the red on the map should be where the equator is or near the equator. That's where it should be at. Now watch this. Look at this one right here. Look at this one right here. Now notice, the high tides are going to go where the moon is going at. That's what it's going to do. It's not affected by the sun's gravitational pull, even though the sun got greater mass. Man, this shit is so inconsistent, bro, because the sun is supposed, but they don't say it's more far away. They're gonna say it's more far away. So we're not gonna give them no excuses. We're gonna deal with this moon right here. And we're gonna deal with why in the hell. Listen, we're gonna deal with the fact, and look at this model right here. You got the sun and you got the moon on one side of the earth. But what you gotta say about these tides on a different side of the earth? Now, remember, gravity is supposed to pull everything towards the center of mass. What center of mass is the tides on the other side of the moon and the earth being pulled towards? What part? This doesn't even make no sense. So, watch this. Here's another model right here. You got the moon tide. These models are showing that the gravitational force of the moon tides are stronger than the sun tides, to the point where wherever the moon go, the highest tide will be. But those aptitude maps actually debunk that, because high tides don't follow the moon. High tides are actually done by pressure in the water system and also magnetism. Watch this. Look at this. We're talking about magnetism, electromagnetism. Electromagnetism and pressure is the reasons why these tides behave the way that they do. There's certain magnetic energy that are great in certain parts of the earth, which will give you a lot of that high tide, and certain pressure levels of pressure. This is why every time it's real windy, you can see high tides because of wind pressure and because of electromagnetic downward. Watch this. Look at this. These are electromagnetic currents on earth ground. Look at this one. These are the electromagnetic currents. So, and as you can clearly see right here and pay attention to them, you can clearly see the measuring of electromagnetic activity. You can clearly see that. So, when a lot of people make those claims about gravity is pulling that, no, and not only just that, but you got pressure from the wind. You got wind pressure that actually causes these things to happen. So let's continue. So now, when I go back to my presentation right here, remember gravity is supposed to pull on greater masses. This is what gravity is supposed to do. It's supposed to pull on greater masses more than it actually pulls on lesser masses. That's what it actually supposed to do. It's supposed to pull on greater masses than it actually pull on lesser masses. So the greater gravitational force is on an object is due to the greater mass of that object. If the greater mass is not, if the mass of the lesser object, of the object with less mass, gravity is going to be less effective. Gravity is supposed to curve things into a sphere. So when a lot of gravitation lovers, they make the claim of gravity is more stronger on objects with greater mass. Well, here's the thing. Here's a drop of water right here. This drop of water is curved. They are curved into perfect spheres. Look at them. Look at this one, as I just showed. This one was curved into a perfect sphere. This is what it was actually did. It was curved into a perfect sphere. So gravity was actually strong enough, even with this small water drop as mass, gravity was still effective on this water drop enough for this drop of water to become a perfect sphere because gravity is exerting all that force in the center of it, which causing it to become a perfect sphere. But if that's the case, then my puddle of water, my puddle of water has more mass than that drop of water, but yet you don't see nam bulge, you don't see nam curvature, you don't see none of that. Not none of that from gravity. Even if they want to say, oh well, the puddle is curved, you just can't detect it. Damn, the drop of water has less mass than a darn puddle of water, and we could detect every aspect of the curvature of that drop of water to the point where we could see a whole sphere. But yet, this cup of water, this drop of water, we can't even detect it. Gravity is not even strong enough for us to detect the bulge in the water, but gravity is strong enough for us to detect the bulge in a spherical shape of the darn drop of water, than a which has lesser mass than a puddle of water. Look at this. My drop of water, listen, my cup of water is also flat, even if you want to say it's curvature, it's undetected. Why is it undetected? Why is gravity so weaker that it can't detect, that we can't even, it's so weak that we can't even detect the curvature of the water with the human eye at the surface of the water? But yet a drop of water can be so effective taught by gravity that it could curve to a perfect sphere and anybody could detect it no matter how small that drop of water is. That's crazy. So gravity is selective. Gravity pulls on certain part water in the ocean and just leaves certain parts of the ocean alone, which is called tidal nodes. This is crazy. This is crazy. Have a nice day, man. This is crazy. So, what people need to understand is this right here. Gravity is indeed not real, and we just proving the contradictions and the illogical aspect of gravity. That's what we're actually proving. We're proving that according to them, gravity should be selective, but we know a force ain't selective. A force always gonna work on something the same way it always work on something. But gravity pick and choose where it want to work in. It pick and choose the amount of mass it want to deal with and all that. Gravity is very, very stubborn for a force. Gravity is very, very stubborn for a force to a point where drops of water, the only thing that can be curved into a perfect sphere by gravity is drops of water and planets, according to, because they say that the Earth is a sphere, so they can so gravity can make the sun, planets, and a drop of water a sphere. But everything from a pint of water to a cup of water to a puddle of water to a gallon of water to a river to an ocean to a bayou, gravity says fuck that. And not only do gravity say fuck that, what about the Milky Way? Because I showed the Milky Way earlier, but I was on mute. Look at the Milky Way. You got a flat Milky Way, bro. You got a flat, look at this. You got flat Milky Ways. Why ain't the Milky Way spherical? Because the Milky Way got greater mass than a damn freaking Earth. But yet the Earth is spherical and gravity need more mass to be effective on object. Watch this. I'm about to show y'all what is the mass of the Milky Way. Watch this. The mass of the Milky Way is 890 billion to 1.54 trillion times the mass of the sun. Gravity can curve the mass of the sun into a sphere because of the mass that it has, but gravity can't curve the universe. Gravity can't curve the universe. It can't curve the Milky Way into a sphere, to a perfect sphere. But yet you get a darn swirl. You get a flat swirl. This is crazy. So, which one is it? I thought y'all said gravity. So, according to y'all own logic, gravity can't need more mass because it can't even curve the Milky Way. It can't even curve the Milky Way. It can curve a planet into a sphere, but it can't curve a Milky Way. It can curve a drop of water into a sphere, but it can't curve a cup of water into a sphere. It can't curve a puddle of water or nothing of that amount. It can't even curve a pint of water. Now watch this. Let me go back to my presentation because this is crazy. I'm not even on the sixth slide already, and gravity already dead. Newton's law of gravitation. Gravitation. Yeah, gravitation. Uh oh my god, man. This stuff is making me sleepy. Force constant, which is the gravitational force between two objects. You got gravitational universal gravitational constant. You got mass one, mass two, which is the mass of two objects. You got the radius or the r, which is the distance separating the centers of masses of two objects in meters. So you got to do that in meters. So, so this is what it is. And then when they get down to the calculation, they calculated and concluded that the accelerating motion of gravity at a downward force is 9.81 meters per second every second, or 32.2 feet. So pretty much taller than a two-story building. So according to scientists who believe in gravity, every object on the earth should fall at 32.2 feet every second per square. So I'm gonna break down this second square so people could get an understanding. When it say 9.8 meters per second square, it's saying 9.8 meters per second every second. When you look at the rising of a body, 9.8 meters per second every second. So let's go to the falling part because gravity causes things to fall. In 1 second, gravity would have been an object would travel 9.8 meters in the first second, the second, 19.6 meters, the third second, 29.4 meters, the fourth second, 39.2 meters. That's what they saying for every object. Well, that's crazy because a piece of paper can't, because that means that every object should hit the ground at the same time, no matter how much mass they have. Now, we know that ain't true because we got to account for friction, which stops that already. The mass of both of the objects that's falling and the medium that they're in. The greater object has against the medium that they're in is based off the resistance. I mean, it gives them that resistance. So when an object falls when a bowling ball falls in the air at the same time of feather fell, the bowling ball is going to hit the ground faster because it has so much greater mass that it's gonna have resistance against the medium that is in. It's gonna literally have resistance against the medium that is in. A feather don't have that much mass, so it don't get that much resistance around the medium that is in. It's the same thing. So the denser, so everything depends on mass. The greater the mass is, the more resistant. The amount of mass depends on the amount of resistance. This is why you could drop a bowling ball, a beach ball in the air, but yet but it won't fall in the ocean. It won't sink in water, in ocean water, or any type of water in the ocean. It won't sink. Even if you press down on it, no matter how much, due to the air that is in there, because air is less denser than water, 8 times less denser than water, the beach ball is gonna pop back up and then float back on top of the water because it doesn't have enough resistance from the density of water. And due to the amount of density that water has, it doesn't, and due to the amount of density that the beach ball has, it doesn't have any resistance. So it's going to float back up. That's called buoyancy. When an object lacks the resistance that is capable or compatible for the medium that is in for it to sink, it goes the opposite direction, which is buoyancy. So now we're going to go back to this gravitational equation right here. We can go to this gravitational equation. And as you can clearly see right here, and this is just a small presentation, but you can clearly see right here that we're going to have to understand how much force is being applied on a person with this equation. This is Newton's law of gravity. So what I did was I broke down the math myself. I took F equals G m1 times m2 divided by d squared. G equals the gravitational constant of 6.67 times 10 to the negative 11 power. Mass 1 is the mass of the earth. Mass 2 is the mass of the object. Mass 2 is the mass of the second object, which is the human. Distance equals the distance between the center of each mass. So we got gravitational constant times 10 to the negative 11. That's what gravitational constant is, 6.67 times 10 to the negative 11. Mass 1, which is the mass of the earth, which is 5.97 times 10 to the 24 power kilogram, or you can call that sectotrillions. The mass 2 is 200 pounds, or a 200-pound human, or a 90-kilogram human. The distance between the center of mass of the earth and a human is 6,378 miles, or meters. Yeah, 6,378 miles. So when you multiply that, you multiply F equals 6 times 6, 7 times 10 to the negative 11 power times 5.97 times 10 to the negative power, 10 to the 24 power times 90 kilograms divided by 6,378 miles square. And so my calculations, I went and got 885 point, 885.995 divided by 400. 880,407.883862 newtons of interaction with a 200-pound or 90-kilogram human being, or not 190,055,648 pounds of pressure on a human being. So this type of pressure will kill us. So unless you Superman or something like that, unless you're Superman, or unless you got some type of superhuman ability, you're not withstanding that force. You really not withstanding that force at all. That's not gonna happen. You're not withstanding that force. That's point blank period. So let me get off this real quick. I just wanted to do a simple presentation and to start off my show. So let's get back. Let's get back to it. So I am the flat earth guy. And I just wanted everybody to actually understand about the concept of gravity and I will be doing the part two. So I will be actually doing the part two and letting people know, because what I'm gonna do is I'm gonna actually do a series on this. I'm gonna actually do a series. So I'm gonna get ready and close out with some music.